In this lesson, we will learn to solve radical equations of the given form through solution of examples. Let's get started with the example number 1, where the given equation is 3x squared plus 15x minus 2 times square root of x squared plus 5x plus 1 equal to 2. In this type of equation, whatever is in the square root, the same thing can be made outside. For example, here if it was ax squared plus bx plus c, then we have something similar along those lines. Ax squared plus bx, at least the first two variable terms are same, or they might be multiples of ax squared plus bx, but you will see through the example that whenever we will make substitution inside the square root, the same substitution will work outside for the first term. Let's take a look. Here, let this part of the equation x squared plus 5x plus 1, and that's how we are going to do always with this form of the radical equation. We are going to assume this part of the radical equation equal to y. And now, using this, we will create y squared for the variable terms in the equations, where these are 3x squared plus 15x. So if we take square on both sides, taking square on both sides, what we have is x squared plus 5x plus 1 equal to y squared. But outside, first two terms are 3x squared plus 15x. So if we multiply this equation with 3, then we can get that 3x squared plus 15x. So multiplying both sides by 3 times x squared plus 5x plus 1 equal to 3y squared. So this will give us 3x squared plus 15x plus 3 equal to 3y squared. Since in the equation we only have 3x squared plus 15x, so the constant term plus 3 must be moved on the other side. 3x squared plus 15x equal to 3y squared minus 3. Let us substitute these values in equation number 1. Substituting these values in 1, we get substituting these values in equation 1, what we have is 3y squared minus 3, and then minus 2y equal to 2. Yes, that is equal to 2. Now we will solve this quadratic equation, which is quadratic equation. So by making this substitution, we have reduced the given radical equation into quadratic form, and then we can apply one of the methods available for the quadratic equation to find the solution. So this is 3y squared minus 2y minus 5 equal to 0. And now we will solve this by using factorization. Here a is equal to 3, b is equal to minus 2, c is equal to minus 5. Since AC is negative, so we will find two such factors of 10. Since AC is equal to 3 times minus 5, which is equal to minus 10, less than 0. So find two factors of, let's do it here, 3y square minus, instead of writing 2, we will write now this 2 as 5 minus 3. 5 minus 3 y minus 5 equal to 0. So this will become 3y square minus 5y plus 3y minus 5 equal to 0. And if we take common y from the first two terms, this will give us 3y minus 5, and we take plus 1 common among the last two terms. This will give us 3y minus 5 equal to 0. This is the checkpoint. Both of these must be same. So we are going to take common 3y minus 5 into y plus 1 equal to 0. This means 3y minus 5 is equal to 0, or y plus 1 is equal to 0. If this is equal to 0, then we get y is equal to 5 over 3. And if y plus 1 is equal to 0, then we get y equal to minus 1. Let us not forget originally what y was equal to. Basically, y was equal to x square, so replacing y by x square plus 5x plus 1 square root. So we will have x square plus 5x plus 1 equal to 5 over 3, and also on this side we will have, so this is square root, x square plus 5x plus 1 square root equal to minus 1. So taking square on this side, on both sides, this will give us x square plus 5x plus 1 equal to 1. 1 can be cancelled on both sides, and we have x square plus 5x equal to 0. If we take x common, that will give us x plus 5 equal to 0. Means x is equal to 0 or x is equal to minus 5. Similarly, we take square on both sides. Taking square on both sides, we'll have x square plus 5x plus 1 equal to 25 over 9, and then taking multiplying 9 on both sides will give us 9x square plus 45 x plus 9 equal to 25. And from here we get 9x square plus 45x minus 16 equal to 0. And here a is equal to 9, c is equal to minus 16. As AC is negative, so we are going to find two such factors of 9 times 16 whose difference is equal to 45. Using factorization method, so this will be 9x square plus 48 minus 3. These 48 and 3 are two such factors of 144, which is in fact 9 times 16 is equal to 144. So this is x minus 16 equal to 0. So here 9x square plus 48x minus 3x minus 16 equal to 0, and taking 3x common will give us 3x plus 16 minus 1 common and will give us 3x plus 16 again. This is a checkpoint. This must be same on both sides. So now let's take common 3x plus 16. That will leave inside 3x minus 1 equal to 0. This means 3x plus 16 is equal to 0, or 3x minus 1 is equal to 0. If this was equal to 0, then x is equal to minus 16 over 3. And if this part was equal to 0, then x is equal to 1 over 3. So the solution set for this kind of radical equation is equal to 0 minus 5, 0 minus 5 minus 16 over 3 and 1 over 3. So that's how we do solution of radical equations of the given form. Let's do one more example. Example number 2, and here the given equation is x square minus x over 2 minus 7 equal to x minus 3 times square root of 2x square minus 3x. 2x square minus 3x plus 2. Apparently, whatever is inside the square root, we are unable to see it on the left side, but take a look on this x. So we got to move this x on the left side as well. So this will give us x square minus x by 2 minus x minus 7 equal to minus 3 times 2x square minus 3x plus 2. Initially, we know that whatever is in the square root, we want the same thing outside as first two terms, so that when we replace this square root expression equal to y, this might be equal to y square. Let's have this added minus 3x by 2 minus 7 is equal to minus 3 times 2x square minus 3x plus 2. And now let's multiply 2 on both sides. Multiply 2 on both sides of equation. This will give us 2x square minus 3x minus 14 equal to minus 6 times 2x square minus 3x plus 2. And now this is exactly whatever is inside. This part is exactly whatever is inside the square root, the first two terms. So we are well on our way. Let y is equal to 2x square minus 3x plus 2 square root. If that is equal to y, then taking square, y square will be equal to 2x square minus 3x plus 2. Because 2 is not available here, therefore we can write it as y square minus 2 is equal to 2x square minus 3x. So replacing these values of y and y square minus 2 in equation number 1 here, replacing in equation 1, we have y square minus 2, y square minus 2 minus 14 equal to minus 16y, which is a quadratic equation in y, which is quadratic equation in y. So we always try to convert the given radical equation into a quadratic equation, which we have done successfully. Now we will standardize it and then find the solution. So this is y square plus 16. This is equal to, it's only 6, not 16. So this is in fact minus 6. So this is y square plus 6y minus 16 is equal to 0. So once we have this, we can find the solution of this equation, and this will give us y square plus 8 minus 2y minus 16 equal to 0. And now we can simplify it further, plus 8y minus 2y minus 16 equal to 0. And this, if we take y common, this will give us y plus 8 minus 2 common, y plus 8 equal to 0. Y minus 2 into y plus 8 equal to 0. So either y minus 2 is equal to 0 or y plus 8 is equal to 0. If y minus 2 is equal to 0, then y is equal to 2, and on this side y is equal to minus 8. Now we will replace y by the original value. What was the original value? That was 2x square minus 3x plus 2 square root. That is 2x square minus 3x plus 2 square root, and this way we will have 2x square minus 3x plus 2 square root equal to 2 on this side, and on this side we have 2x square minus 3x plus 2 square root equal to minus 8. And from this, if we take square, this will give us 2x square minus 3x plus 2 equal to 4, means 2x square minus 3x minus 2 is equal to 0. And now we can find solutions for this. Because AC is negative, therefore we need to find difference of 4 whose factors of 4 whose difference is equal to 3. 2x square minus, instead of writing 3, we'll write 4 minus 1, x minus 2 equal to 0. 2x square minus 4x plus x minus 2 equal to 0. And here we will have 2x common, which will give us x minus 2 plus 1 common and x minus 2 equal to 0. If we take x minus 2 common, that should give us 2x plus 1 equal to 0. Since the product of two real numbers is 0, so either x minus 2 is equal to 0 or 2x plus 1 is equal to 0, and this gives us values of x equal to 2 and minus 1 by 2. And now we are left with this other part. Here we have 2x square minus 3x plus 2 equal to 64 if we are taking square on both sides. So this will give us 2x square minus 3x minus 62 equal to 0. Here a is equal to 2, b is equal to minus 3, and c is equal to minus 62. And this we can use the values of a, b, and c in quadratic formula. So using quadratic formula, we have x equal to minus b plus minus b square minus 4ac divided by 2a. And now when we substitute these values, we get x equal to 3 plus minus square root of b square is 9 minus 4 times a is 2 times minus 62 divided by 2 times a, and 2 times 2 is 2a. So this gives us x equal to 3 plus minus 9 plus 496. 496 divided by 4, and the values of x would be equal to 3 plus minus 505 divided by 4. So the solution set would be equal to 2 minus 1 by 2 and 3 plus 505 square root divided by 2 and 3 minus 505 divided by 2. That is solution set for this kind of radical equations, and we'll see you in next lesson with another type of radical equations.